Welcome to our introduction on model-driven engineering and continuous integration and continuous delivery. This is an MDE seed corn funded project. Hopefully you enjoy our content. Let's start by setting a scene that motivates the use of MDE and CI/CD. So if a company is going to be developing a domain-specific piece of software, a domain being an area of expertise or knowledge, the software development team that is creating the software system is at some point going to require some specialist knowledge of experts within that domain, such that they can build an intricate component within the system that is going to then offer some sort of utility or a problem that the domain needs to tackle. So in terms of software, this could be the software implementation of a physics problem or some maths, maybe a simulation of a particular engineering problem. And a domain expert is going to need to explain how that software component should operate, be that understanding the principles of thermodynamics or something more unique about a particular interaction between an environment and a system. The knowledge that the expert is going to give to our software engineering team is going to usually be communicated through some sort of documents or pictures. And the expert may not be knowingly trying to confuse our software development teams, but the language that they use is likely going to be that of their domain expertise, which may not be common language that our software development team understands. And thus we have an invisible barrier between our expert and our software engineering team that is going to lead to some sort of miscommunication and misunderstanding. And then problems will ensue with our software project, be that we're now over budget, running behind schedule, or that our software implementation of a certain component is flawed. The logic is wrong in it and it simply fails. These are the kinds of problems that affect software development projects even to this day. And we have been doing software development for decades, but these problems still exist. So an alternative to many of the approaches out there, which may include turning our experts into software developers by giving them access to easy programming languages, or coming up with a methodology or a strategy of rapidly testing ideas that fail, hopefully soon, and we overcome the problems one after another. There is another approach that we could take, and that would be to communicate with models. Using model-driven engineering, and for our examples we'll be using Epsilon, we will demonstrate how you can create a comfortable modeling language for your experts to use. So this is similar to the idea of giving them a programming language and asking them to simply write a program. However, unlike a programming language, we will tailor the language to the domain expert's language, or domain language. The domain expert can then go away, build a model that suitably expresses whatever component or problem that we've got. And then from that model, we can then perform transformations and generate code that we can hand to our software developers, such that the software developer team do not necessarily need to know the full depths of the problem that they're trying to solve with this unit of software, but it is given to them in a way that they can operate and understand it. It sounds easy, but MDE tools are not necessarily easy or quick, and the application of creating a modeling language or modeling in itself is quite challenging. Now, in a world where we're striving to deliver software faster, we are left with a bit of a challenge, which is how do we quickly bootstrap model-driven engineering toolsets so we can make making a modeling language and models of complex problems easier and quicker. If you're not very comfortable with what the idea of MDE is, then you can have a look at MDE which is on YouTube and has a video, which is What is MDE? And from there, you can then go and explore some of the other experts' ideas about what MDE is and is not. So one of the quickest ways that you can get started with something like Epsilon, which is an MDE tool, is that you can use them in some sort of an online setting. Epsilon has a very good demonstration of this, and they provide the Epsilon Playground, which is a website. You can go to the website and you can create your own modeling language, known as a meta model. Using that, you can, within the same page, then create a model with that language and write short programs which can then either transform that model to code or other text forms, other models, or perform validation tasks. check that a model conforms to some sort of rule set. All of these programs can be executed within the playground online. You do not need to install anything on your machine, you do not need to compile any software, and there are links within that playground space to the documentation for the relevant components. Once you've created your modeling language, model, and a program, you can then export it from the playground, and you do that through a download process. You can take it away in Ant, Gradle, Maven, whichever form you require. If you'd like to know more about how to use Epsilon, there's a YouTube channel for the Eclipse Epsilon environment, which will take you through some tutorials and get you started with how to use Epsilon. But the Epsilon playground also demonstrates some of the limitations. The playground itself is not intended as a full development environment. It is not very easy to save and reload your project. You can't version control the work that you've done within the playground. And it's not very clear how, if you've developed a modeling language in there, how you would then hand that to an expert and say, here, can you make me a model with this? The next limitation with the playground comes down to the model management, or the model management processes. Whilst the playground has given us an environment that we can run a program, such as a model validation, after we've performed a validation, we'll probably likely want to then run a second program, which would do, say, some code generation. So now we have multiple programs needing to be executed against our model. And it again is not clear how you could do this within the playground environment. There's a lot of manual processes around the use of the playground. So once you've developed your model and you've generated your code, you then have to download it. You then have to unpack the download file that you get, remove the software, say if you generated a Java file, you would need to remove that from that pack and then transfer that somehow to your software developer team. So we could imagine that this now breaks out into downloading a file, attaching it to an email, emailing it across the software developer team. This does not link into any modern version control system for software development. Now, ideally, if our teams were operating within a Git space, our generated code should be inserted into Git repository for the software project, not sent via email. Somebody needs to version control it and upload it to the repository such that the software team, as they pull from the repository, are getting the latest version. Whilst I might talk negatively about the playground in itself is a very good achievement, and we should not underestimate that. However, it does have some limitations if you were to use it at scale for software development. So the next stage would be to take our skills that we've learned within the playground and evolve them into then using an offline environment. Go back to more of an IDE on our local desktop machines. Epsilon uses the Eclipse IDE to provide a suite that would let you do everything that you can do on the playground on your local desktop machine. And indeed, the downloads that you get from the Eclipse playground are intended to be loaded into an Eclipse IDE so that you can continue to work on them. And this then gives us the ability to link into a Git repository and start version controlling our changes to our model as we develop them. So we can start in a meeting with the Epsilon playground. We can have a discussion. We can actively start developing a model. After that meeting, we can take the download. We can then bring it into our IDE. And now we can start improving and refining that idea. So now we can create a language. We can make a model. And we can start creating some automated tasks, such as validation, code generation. We can do that in a modern IDE with the modern conveniences that you expect. A graphical environment, syntax highlighting, debuggers, execution environments. And the modeling project itself can now be versioned and shared through more common utilities like Git, where you can now branch, version, merge, and review the development of a model. However, again, there are limitations to what you can achieve within this space. We've now got added maintenance and upkeep for our desktop development toolset. Now, if there were multiple people operating on the same model through Git, everybody will need to maintain a similar level or version of software for developing and working on the model. We now step into the next problem, which is how are we going to get our domain experts to do their modeling? Are we going to give them a full Eclipse IDE environment, have them then push the changes that they make to a Git repository? If our experts are not very comfortable with these tools, then maybe we end up having to work indirectly. So we give a notation, our modeling language, to our experts, who then simply write it up in a text editor, or possibly even a Word document. They then push that back to our project administration team, who then upload it into the Git repository and proceed to update the models with the changes. And yet we still end up having to do some sort of manual processes around our model. So we're still going to have to run the validation programs manually. We're still going to have to run the generation manually. We're still going to have to run any tests on the code. And somebody somewhere is going to have to take our generated code from our model repository and move that over to the developers. So again, we're still stuck with a number of manual processes that are involved when modeling to generate sections of a software system. So at this moment, you're probably wondering, well, you've just listed all these problems. Why on earth would we want to use model-driven engineering? Well, the advantages of model-driven engineering are actually well documented. Needless to say that model-driven engineering is used to make some of the really important systems in our lives, be those around control systems for aircraft, software systems that run the engines of our cars. These systems exist. They are built to very high standards. Companies that build them are expected to conform to very high standards that can be rigorously inspected and administered by a third party to ensure that they're compliant. This then prevents serious accidents within the world. It is not perfect, but needless to say, it is a lot better than having a completely unregulated environment where anybody is writing a piece of software that could endanger the lives of others and releasing it upon the world. So it is difficult to take the ideas of MDE, which can deliver these quality systems, and bring them to a small scale where we can quickly and cost effectively build rigorous tested software that hasn't taken a lot of effort to bootstrap tools, to learn languages, to develop languages, to produce software assets. But at this stage, you might be thinking that software development is quicker. We can just dive in, start writing the code. But is software development still slow and costly? But because it is more commonplace, are we generally accepting the fact that it is what it is? That yes, it takes time to develop software. However, I can see progress in it because I can see my teams writing lines of code, I can count lines of code per day, I can compile, I can test, I can rapidly release new versions of my software if it breaks. Over time, things have improved for software engineering and software development, be it through IDEs, methodologies, teaching practices. But how do we bring some of those benefits back to MDE? We need MDE to move faster, like software development does. Let's stand back and have a look at how software developers work these days. A software developer has a similar problem to the MDE problem, which is that there is a certain amount of manual processing required to turn their code into some sort of usable software product. And the production of that final binary, as it were, that will be executed on a machine is or was a slow and error-prone process. So you'd want to validate your code before trying to run it through the compiler, particularly if it was a very large binary that you were going to compile, simply because you don't want to go through half an hour of compilation to find out that one semicolon has just totally ruined your compilation exercise and you need to start over. So we do a validation because it's quick and easy. We weed out those problems and now we proceed to do the build. We build, we compile our code. Brilliant, we have an executable. Maybe it's taken several hours to build. Next thing we do is put that into a test and we run it through a number of stages and we want to make sure that, yes, actually, this binary version does work. And then we move to deployment. How do developers do that these days? They automated it. It's called continuous integration or continuous D. Now, D in this case could be delivery or deployment. The idea being is that if it was delivery, you would be generating a piece of something that then sits in a repository that can be used. If it was deployment, you're taking something that you've built and putting it straight into a live system. So CI/CD is the automation of the software building process. It's quick and it's robust. So the answer that MDE needs to possibly be considering here is the use of a CI/CD pipeline to automate some of the model management processes and to remove some of the overhead between the different model management processes. But now we have a problem. MDE tools will need to be adapted for a CI/CD pipeline. Most MDE tools have been built around the idea of a graphical user interface, with the point and click of a mouse being the primary way to engage with the tool. This is because MDE has grown up around the idea that graphical representations for modeling can make it easier to understand the problem or express a problem such that an expert can come in and create in a comfortable way and deal with the complexities of the problem as opposed to trying to understand the quirky syntax of a programming language. Unfortunately, this has now led to a problem where most MDE tools are inherently dependent on a desktop graphical user interface being available. Be this because they need some sort of level of interaction through a yes/no prompt, or simply that people have inadvertently left in checks for software components that are part of the GUI being tested as part of the processes. This is completely incompatible with a CI/CD pipeline, where there is no graphical user interface. Most developer tools that go through a CI/CD process are going to be driven purely by script, without the use of a GUI in any area of it. Everything has to run unattended, everything has to run to a script, everything has to produce some sort of textual output that can be observed after the process. So we're left with a problem, and that problem is that our MDE tools may not, in many cases, be compatible with the CI/CD environment that we need to execute them under. So whilst we have this sort of natural progression of the idea that we should take MDE and CI/CD and combine them, the GUI dependencies that we've got, making it impossible in some areas. How are we going to convince MDE toolmakers that there's an audience for CI/CD such that they should go away and spend the time and effort to convert their tools over to be operating within a CI/CD pipeline? Well, the only way to do that would be to have people starting to use MDE tools in a CI/CD way. But they can't do that because they haven't got the tools, such that we now need some way to provide the tools without anybody having to do any extra work. And there is a way to do this, and we can do this today. If a tool has been created within the Eclipse IDE, which most MDE tools are, then it is possible to operate the Eclipse IDE environment without a GUI attached, which basically gives us a way to cheat dependencies on the GUI in most cases without the need for the tool authors to rewrite large sections of their code base. Full disclosure on this, our demonstration is going to use Epsilon, and Epsilon can be operated outside of the Eclipse IDE environment. However, for our examples, we will not be using those techniques, and we will be using the Eclipse IDE environment to operate Epsilon. The goal of our work is simply to improve or make it easier to apply MDE tools and techniques to software projects using CI and CD style approaches for developing models. Most of these tools are going to be based on the Eclipse IDE environment. As such, we need a way that we can then manipulate and change the Eclipse environment to operate within a CI/CD pipeline. So what do you need to know at this point? Depending on your background and your skills of expertise, you're going to either need to start from knowing how to operate Epsilon, in which case we have a follow-up video for that. Maybe you already know how to do model-driven engineering and you're more interested in how you can create pipelines, in which case you can skip our Epsilon video and move straight into the CI pipeline and using an existing container within a CI pipeline to perform modeling tasks. And the final stage of our demonstration, we are going into the technical details, how you can take the Eclipse IDE, operate it in a headless way, such that you could apply that to either your modeling tool or a modeling tool that you use, which is based on the Eclipse IDE, and develop out your own CI/CD platform. But ideally, what I hope you take away from this is that you understand that MDE is an important way to develop certain software systems. Yes, we understand that it is a somewhat costly and effort-driven approach to designing software, but that those costs don't have to be too high, and that by applying some CI/CD techniques, actually you can get the qualities that MDE can deliver in a much quicker and easier way, funnily enough, using the same techniques that software engineers use to deliver quick software.